Good evening, children. Good evening, online children. Good evening. So we have only Gayatri and Giant online today. Okay. Online children, I've shared my screen. Is it visible to both of you? Okay. Okay. So this will be the last session on linear equations. We'll wind up this chapter with these MCQs. I think I have about 15 to 20 MCQs. We'll discuss them, and we are done with this chapter. All right. Okay. Yeah. See the first one. Read. Yeah. Come. Yes, we've begun the session. Please see the question on the board. Yeah. What's the answer? Correct. Infinitely. Very good. Infinitely many solutions. This one. So we know that a linear equation in two variables x and y is represented by a straight line in the Cartesian plane. So which of these graphs is a straight line? C, option C. We know that a linear equation in two variables x and y is represented by a straight line in the Cartesian plane. So option C here shows the graph of a straight line. So option C is the correct option.
Mom, C.
C.
Yes, ma'am.
Okay, correct. Why? Because 7 into 3 plus 3 into 7 is equal to 21 plus 21, which is 42, which is the RHS, right? LHS. Okay, LHS, when you, in the left-hand side, when you use X is 3 and Y is 7, you get 42, which is the RHS. So option C is the correct option. Which one of the following is a solution of the linear equation? So whichever ordered pair satisfies the equation is a solution. Whichever ordered pair, all these four options represent ordered pairs, right? What are they called? They're called ordered pairs. Now, whichever ordered pair satisfies the linear equation is the solution to the linear equation. So how do you know if an ordered pair satisfies the equation? So you need to use the x and y values in the left-hand side and work the left-hand side. And the answer you get should be equal to the value on the right-hand side, which means the ordered pair satisfies the linear equation. Okay, so option C is the correct option. So y is equal to A is a line parallel to the x-axis or y-axis. Y is equal to A is a line parallel to the x-axis or y-axis. X-axis, because whenever it is y is equal to, whenever it is y is equal to a constant, that line is always parallel to the x-axis. So we have two options. It can be above or below. The line can be above or below. See, the equation is y is equal to a. Y is equal to a, right? So y is equal to a because it's y is equal to, it's a line parallel to the x-axis. Is that fine? Now the graph of y is equal to a lies below x-axis. So they are asking about this one, lies below. Okay, so it lies below the x-axis when a is negative. When a is negative, right? That means a is less than 0. When a is negative, meaning a is less than 0. A greater than 0, meaning a is positive. A greater than 0, meaning a is positive. A is equal to 0, which means a is equal to 0. A less than 0, meaning a is negative. None of these, right? So the graph of y is equal to a, we know is a line parallel to the x-axis. And it's given it's below the x-axis. Now the question is, what will be the meaning? What is the condition for a here? A will be less than 0 because it's below. Below, it's negative. All these values are negative, right? -1, -2, -3, and so on. Okay, so option C. You may have to do some rough calculation and answer the question. So don't write the question, just work and let me know the correct option. What's the value of m? What is the value of m?
-17/2.
-17/2.
Yes, ma'am.
Okay. Okay. So m into -2 plus 2 into -1 is equal to 15. -2m -2 is equal to 15. -2m is equal to 15 plus 2, 17. So m is equal to -17/2. M is equal to -17/2. Right? Okay. Yeah. Option A. Yeah, which is the correct option? Yeah, you're right. Yeah. It's waiting for the others to finish. Option A. Correct. Option A. Because all these ordered pairs satisfy this equation. These three ordered pairs satisfy this equation. So they are the three solutions. Now in this option, you can see when you use 1, 0, here, 2 into 1 minus 0. 2 1s are 2, minus 0 is 2, but this is 1. So this ordered pair does not satisfy. This ordered pair does not satisfy this equation. So like that you can check, you will have to check. So in option A, you can see that all these three ordered pairs satisfy this equation. That is when you use the x and y values in the left-hand side and evaluate, the value will be equal to 1, which is the right-hand side. Correct? Option A is the correct option. No, Sanjay and Rahul, no talking, please. Option A is the correct option. All right?
Mom,
Yeah.
Mom, can you explain -2 and -5? Like, I'm a bit confused. Like, it's -y, so how should I take it? How should I take -5?
Okay, 2x, 2 into -2, minus 5. So it's -4 plus 5, which is 1.
Yeah, I thought minus should not come.
Y is -5, right? So you can see minus, this is y.
Okay, fine, thank you.
Okay. Okay, so she was asking about this option. So x is 2, 2 into -2, minus, what is y? -5. So it's -4 plus 5, which is 1, which is the RHS. Okay. So we know that a linear equation in two variables x and y has infinitely many solutions. A linear equation in two variables x and y has infinitely many solutions, and it is represented by a straight line in the Cartesian plane. And we know that a straight line has infinitely many points on it, which is why a linear equation in two variables x and y has infinitely many solutions, because the line has so many points on it, and every point on the line will satisfy the linear equation. But look at this question. The equation 2x plus 5y is equal to 7 has a unique solution if. So not to get confused, 2x plus 5y is equal to 7 is a linear equation in two variables x and y, and it has infinitely many solutions. But here the question is, when will it have a unique solution? When will it have a unique solution? So I'll just tell you, it'll have a unique solution when x and y are natural numbers. Okay, see, when you consider the points on the straight line, do you think every point will be a natural number? Like now the address of this point, do you think it will be a natural number always? It can be -2, -3. It can be rational. On a number line, you have on a line, you can find both rational and irrational values, right? On a line, you can find both rational and irrational values, positive and negative values. So when we say a linear equation in two variables x and y has infinitely many solutions, that is when x and y are real numbers. When x and y are real numbers, for real values of x and y, yes, it has infinitely many solutions. But if x and y have to be natural, I'm sorry, if this equation should have a unique solution, then x and y have to be natural numbers, because see, then only one solution. 2 into 1 plus 5 into 1 is equal to 7. So x is equal to 1, y is equal to 1, where 1 and 1 are natural numbers. Now tell me another pair of natural numbers which will satisfy this equation. Tell me another pair of natural numbers that will satisfy this equation.
Mom, only 1 and 1.
So when x and y are natural numbers, it has a unique solution. But it has infinitely many solutions because x and y can be real numbers. X and y are only natural numbers. We say this equation has infinitely many solutions for any real value of x and y. But if it should have a unique solution, then both x and y have to be natural numbers. So you can see when x is 1 and y is 1, the equation is satisfied. 2 into 1, 2, plus 5 into 1, 5. So 2 plus 5, 7, which is the RHS. The equation is satisfied. And you can see that x and y are natural numbers. Now there is no other pair of natural numbers that can satisfy this equation. So this equation has a unique solution when x and y are natural numbers. So it's a very, like it's a situational question. Don't think it's always true. It's not always true. Okay. So not confused, no? Linear equation in two variables x and y has infinitely many solutions. Infinitely many solutions. So here the condition is if x and y are natural numbers, then it has a unique solution. All right? Okay. Correct. Correct. 2 into 2 plus 3 into 0 is equal to k. So 4 plus the 0. So 4 is equal to k. K is equal to 4. Correct.
Mom, is it minus 9 comma 0?
Minus 9 comma 0. No. Option C. Yeah? Okay. Okay. So Gayatri said A. Now here some of you say C. D. Option D. Okay. You also say option D. C. Okay. C. D. Okay.
Option C, ma'am.
Mom, I say option D, not A.
Okay. So you change your mind. It's not option A, it's option D. Okay. All right. So 2x plus 0y plus 9 is equal to 0. 2x plus 0y is 0. Okay. So why are you blushing? Don't think of something that happened in school between your friends and blush now in the class. Huh? You didn't go to school today. That's why you're blushing then. Okay. So 2x plus 9 is equal to 0. 2x is equal to minus 9. X is equal to minus 9 by 2. And how have we understood this? X is always minus 9 by 2. X is always minus 9 by 2 for any value of y. For any value of y. Any value. So like any value. Any value. Any value. Any value of y. So that means option D. X is always minus 9 by 2. So minus 9 by 2 is fixed for X. Minus 9 by 2. And Y can be anything, comma M. Minus 9 by 2 is fixed. X value, right? So some of the girls were right, you 3 and Gayatri also. The girls win this. I'll just do it again. See, 2x plus 0y plus, actually the equation is 2x plus 9 is equal to 0. Okay. So this is a linear equation in one variable x. Now this is treated as a linear equation in two variables x and y by writing it like this. By showing the missing variable y. Okay. So now when you solve this, of course, it again becomes plus 9 is equal to 0 because 0y is 0. So on solving, you get x is equal to minus 9 by 2. Okay, which means x is always minus 9 by 2. X is always minus 9. X is minus 9 by 2. So x is always minus 9 by 2 for any value of y. Any value, 0, minus 1, minus 2, 100, whatever value for y. Any value for y. So that means x is minus 9 by 2 is fixed. And what can be the value for y or values for y? Anything. M. Minus 9 by 2 comma m is the correct option. All right. The equation that correct. You're right. The equation of the x-axis of the form y is equal to 0. Y is equal to 0 is the equation of the x-axis.
A.
A. Okay.
A option.
B. Y is equal to is parallel to y-axis, huh? Yeah.
A, ma'am.
Y is equal to a constant is a line parallel to the x-axis. It's a positive 8. So it's parallel to the x-axis at a distance of 8 units above the origin. You have to just represent it. In the rough column, maybe you can just represent. So y is equal to 8. Y is equal to meaning the line is parallel to the x-axis. So it can be here like this, parallel to the x-axis here or here like this. But it's a positive 8. So it has to be above the x-axis because it's positive. If it's negative, it's below the x-axis. If it's positive, it's above the x-axis. So now we got it. So y is equal to 8 is a line parallel to the x-axis at a distance of 8 units above the origin, right? Okay, what are the options given here? Let's see. Exact distance of 8 units from the origin, okay. Parallel to y-axis is wrong. Making an intercept, 1 minute. I didn't read all the options, so let me not. The second one is not possible. The third one is making an intercept 8 on the x-axis. I'll tell you what an intercept means. Making an intercept 8 on the x-axis. So that means the line cuts the x-axis at x is equal to 8. Making an intercept 8 on the x-axis. That means the line cuts the x-axis at this marking 8. No, that's not true about y is equal to 8 because it's parallel to the x-axis. So it's not going to make an intercept. It's not going to meet the x-axis, right? No, this line is parallel to the x-axis. So it's not going to cut the x-axis at 8. So this is wrong. Option C is not possible. Making an intercept 8 on both the axes. So here, like making an intercept 8 on both the axes, meaning like this. It cuts the x-axis at 8 and y-axis also at 8. No. Making an intercept 8 on both the axes. Okay, so that means it cuts the x-axis at 8 and y-axis also at 8. No. It cuts the y-axis at 8, but not the x-axis at 8. It cuts the y-axis at 8, right? Because where is it? This is the 8, right? It cuts the y-axis at 8, not the x-axis at 8. Okay? So we need to understand the line. Otherwise, y is equal to is parallel to the x-axis. So there are two positions, below, above. And here it is above. Why? Because positive is. So it's like this. This is the line. Y is equal to 8. And this marking is 8, which means the y-intercept is 8. Which means the y-intercept is 8. That is, the line cuts the y-axis at 8. Y-intercept is 8, meaning the line cuts the y-axis at 8. So the y-intercept is 8. Yeah, y-intercept is 8. Correct. Okay, now read all the options. Making an intercept 8 on both the axes. No, it doesn't make an intercept 8 with the x-axis because it does not cut the x-axis at all. So this is not possible. Making an intercept 8 on the x-axis. No, it doesn't cut the x-axis. Parallel to y-axis. Oh no, it's not parallel to y-axis. This is the correct option. Now you will say it's not clear that it's only 8 units from the origin. It can be above or below. See, this is the best option. See, maybe you will say it's not described very precisely. That's not our problem. BCD cannot be the correct option. So A is the most precise option. So sometimes you have to select the best option. Of the 4, you should select the best. And this is the best. Okay. No, I'm saying that because if you feel the word above is missing, the word above is missing, that's the best option. All right. Sorry. Option C. 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 Because X is 5 and Y is 2. So in equation C, 5 plus 2 is equal to 7. It's satisfied.
Yes,
Okay.
ma'am.
Correct. Option C.
Remains the
Multiply.
same. Remains the same.
Remains the same. Huh?
Yes, ma'am.
If we multiply or divide both the sides of a linear equation with a non-zero number, then the solution of the linear equation remains the same. The equation is not affected. When you do the same changes on both the sides, the equation is not affected. When you multiply both the sides or divide both the sides by any number other than 0, if you multiply by 0, then everything goes away, right? There's nothing. And you cannot divide by 0 because division by 0 is not defined. So if we multiply or divide, what is there? There's a linear equation. There is a linear equation. So there is the left-hand side and right-hand side. When you multiply the LHS and RHS, or when you divide the LHS and RHS by any number other than 0, which of the following is true? Then the solution of the linear equation remains the same. Okay, is the correct option because the equation is not affected. The equation is not affected. Let me just give an example. And now supposing we have this equation 2x plus say y is equal to 3. Okay, and say this is the line. In the Cartesian plane, this is the line. Now you multiply this equation. 2x plus y is equal to 3 is a linear equation in two variables x and y. And let's say that in the Cartesian plane, this is the straight line. It's given by. Okay. All right. Now we multiply this equation on both the sides by 2. 4x plus 2y is equal to 6. Now you make a graph of this equation, you will get the same line. You will get the same line. Same line. You multiply this equation by 10, 20x plus 10y is equal to 30. And you make the graph of that equation, you will get the same line. Same line you will get. See, your plotting points may be different. Maybe first when you meaning when you made the table using this, maybe you plotted these 3 points and you got this line. So later when you made the table for this equation, maybe you get you plot these 3 points and you still get the same line. The plotting points in your XY table may vary, but when you connect those points, it will be the same straight line. All right. Okay. How many linear equations can be satisfied by x is equal to 3 and y is equal to 2? So x is equal to 3, y is equal to 2 is a point, right? 3, 2 is a point in the Cartesian plane. 3, 2 is a point in the Cartesian plane. And we know that there are infinitely many lines that can be drawn passing through a given point. X is equal to 3, y is equal to 2, which means 3, 2. Okay, is a point, is the address of a point lying in the Cartesian plane. And we know that there are infinitely many lines that can be drawn passing through a given point. And 3, 2 will satisfy all those lines because it lies on so many lines. 3, 2 will lie on so many lines because through this point you can draw infinitely many lines. That means 3, 2 lies on all those lines. So how many linear equations? Infinitely many linear equations can be satisfied by x is equal to 3 and y is equal to 2. See here. The point of the form A, A, the point of the form A, A always lies on the line y is equal to x. A, A, right? That means x and y, x coordinate and the y coordinate, they're the same always, like 1, 1, 2, 2, 3, 3, -1, -1, -2, -2. It can be any, it can be like -√3, -√3 also, any real number. But the x coordinate and the y coordinate is the same because A, A. So that means the equation should be y is equal to x or x is equal to y. Anything, x is equal to y or y is equal to x. Okay. Now, I'll just want to say something here. See, now 0, 0 will also lie on this line y is equal to 0, 0, A, A, right? X is 0, y is also 0. That means the line will, this is the line 1, 1, 2, 2, 3, 3, -1, -1, -2, like this. The graph will look like this. The graph will look like this. Okay, so because this is -1, this is -1, this is -2, this is -2, this is -3, this is -3. Here, this is 1, 1, 2, 2, 3, 3. So the line will pass through the origin like this. So now you can see that the line, this point lies on the x-axis, right? It also lies on the y-axis. But that cannot be the correct option because it's given the point of the form always lies on. Always lies on. No. If you take this point, it does not lie on the x-axis or y-axis. This point lies on both the x and y-axis. But every other point does not lie on the x-axis or y-axis, right? I'm not confusing you. Look at this. The point of the form A, A always lies on. Always lies on the x-axis. No, where does this point lie on the x-axis? Does this point lie on the x-axis? No. Does this point lie on the y-axis? Does this point lie on the y-axis? No, this is the only point that lies on both the x and y-axis. But the point of the form a comma a always lies on y is equal to x. Always lies on y is equal to x. X plus y is equal to 0 is not right because 1 plus 1 is 2, not 0. Okay. So option C is the correct option. Yeah, just give me a minute. I need to make a call. Thank you. Got it? Yes, Yarni. Okay, the line M is parallel to which axis? So it will be x is equal to. And it's to the right of the y-axis. So will it be positive or negative? Positive. So like x is equal to a, where a is greater than 0. A greater than 0 meaning a is positive, right? A greater than 0 meaning a is positive. See, it can be x is equal to m also, where m is greater than 0. Okay, x is equal to, sorry. See, it's, don't get fixed with a. And the constant there is represented by a, that's all. X is equal to can be even c, where c is greater than 0. Not that you should use a only. The line M is parallel to the y-axis. So its equation will start like this, x is equal to. So where is x is equal to here? Here, this one? No, no. This is x is 0, no. So here, x is equal to a, and it's on the, it's to the right of the y-axis. So a is positive, a is greater than 0. So this is the correct option. Parallel to the y-axis. So x is equal to a, and a is positive because it's to the right of the y-axis. So a is positive, which means a is greater than 0. Okay. Yeah. B. Okay. B. Okay. So we have father, son, yeah, son, percentage, and 10 years ago. 10 years ago. Age 10 years ago. Correct? Father, son, percentages, and ages 10 years ago. Okay. And we are asked to take the father's percentages X and son's percentages Y. 10 years ago, X minus 10, Y minus 10. 10 years ago, right? Okay. Now, 10 years ago, a father was, so we should use only these expressions. 10 years ago, a father was 10 times as old as his son. So father, this is father's age, was means equal to 10 times, meaning 10 into, times meaning into, 10 times, 10 into the age of his son, y minus 10. Whatever is in English, you're just converting that to, you're just using expressions and writing the equation. See, let me just do it again from the beginning. Make a table to write the assumptions for the fathers and sons present age and ages 10 years ago. So father, son, present ages or present age, ages 10 years ago. All right. So this is X, this is Y. So 10 years ago, X minus 10, Y minus 10. Now the information is about this part of the assumption because you can see here 10 years ago. So then you should not use these ages. In your equation, you should not use these ages because the information starts like this 10 years ago. Then you should use the father's age 10 years ago and son's age 10 years ago. Unless it is mentioned, unless the word present is used anywhere, you should use the ages 10 years ago only. It starts with 10 years ago. That means in our equation, we should use the expressions that represent the father's age 10 years ago and son's age 10 years ago, unless it is mentioned son's present age. Unless you see that word present, you should use the ages 10 years ago only. 10 years ago. Okay, so I'm going to deal with only these expressions to make the equation. 10 years ago, a father was. See, when you read a father was, this is a father, right? Was means equal to. Father was. Now read. A father was, we can change to maths. This is in English. We change that to maths. A father means we wrote x minus 10. Was becomes equal to. Okay, now 10 times. Change that to maths. 10 times meaning 10 into. Okay, this is also over. As old as his son. As old as his son. Son is this one. So we normally use a bracket to represent multiplication when we have an expression. So 10 into y minus 10. Finished. As you read, just substitute with the mathematical expressions. Right? That's all. This is the equation. So x minus 10 is equal to 10y minus 100. Bring everything to one side. So you have x minus 10y plus 90, right, is equal to 0. X minus 10y plus 90 is equal to 0. So somebody said option B, right? Who said? Very good. Others? Okay.
Yes, mom.
Okay. All right. Okay. So x is equal to minus 3, children. X is equal to, meaning it's parallel to the y-axis. Y-axis. So is it right side or left side? Left side, because x is equal to minus 3. Minus 3 here, minus 3. Okay, then y is equal to 2. Y is equal to, so it's parallel to the x-axis. Above or below? Above. Okay, this, okay, next. X is equal to 3. X is equal to 3, so parallel to the y-axis. And to the right of it. Then y is equal to minus 2. Y is equal to, so it's parallel to the x-axis. And minus 2, so it's below. So this is the figure enclosed. This is the figure enclosed. Now, is this a square or a rectangle? Because how many units here? 2. How many units here? 2. 2 plus 2, 4. But here, 3 plus 3, 6. So this rectangle has length 6 units and breadth 4 units. Because this is 3, no? This is 3 and this is 3. So length is 3 plus 3, 6. And the breadth is, this one is 2 and this is also 2. Forget minus 2. We're talking about the length. So 2 and 2. Don't say 2 minus 2, 0. There is length here, 2 units. Here also 2 units, 2 plus 2, 4. So length is 6, breadth is 4, so it's a rectangle. Correct? Option C. Okay. All such points whose y coordinate is, here y coordinate is, y coordinate meaning y, is means equal to 2 more than. Whatever comes after more than, less than should be written first. So what comes after more than? 3 times the x coordinate. You should write that first. So 3 times x coordinate. 3 times meaning 3 into. 3 times meaning 3 into x coordinate is 3x. Now, I said whatever comes after more than, less than should be written first. So 3x. Now write this one, 2 more than. So plus 2. We'll do it again. Y coordinate is 2 more than 3 times the x coordinate. Y coordinate, y, is equal to. There is this, these words, there are these words more than. So whatever is after more than, you should write that first. So what do you see after more than? 3 times x coordinate. 3 times x coordinate meaning 3x. So write that first. Then 2 more than meaning plus 2. This one means plus 2. So plus 2. So y is equal to 3x plus 2. All right. So you can see here this one. When you substitute the values, root 2 into 1 by root 2, correct? Minus root 3 into 1 by root 3, correct? So root 3 cancels. So 1 minus 1 is 0. But it's 1 here. So what is the question? Which of the following is not true? That is, which of the following is false? This one is false. Not true meaning false. You don't have to check everything, See, for you, MCQs, only one option you'll have to, only one option will be the correct option for you. You don't have to spend time. See, MCQs, you'll have to finish. If you're very honest and very sincere, you want to read all the options and you lose time in the exam. So just try to do the easier ones first. If this is not the option, then you think of reading the others. So if you look at this one, because it's easy, is one of its solutions. Let's check. So root 2 into 1 by root 2 minus root 3 into 1 by root 3. 1 minus 1, 0, but it's given 1. So clearly this does not satisfy the equation. So it is not a solution, but it's given it is a solution. So it's false. This one is false. That's what is here. Which of the following is not true? That means which of the following is false? Which of the following is not true? Is false. The following is false about this one. Yeah, this one is false. Because it's given it's one of the solution. No, it's not.
Is it D?
A.
D.
C.
D.
Okay. So x is 2, no? So 2 minus 2y is equal to 8. Minus 2y is equal to 6. Y is equal to minus 3. Then x minus 2 into y is minus 1 is equal to 8. X is equal to, this is plus 2 on the other side, minus 2. So minus 3, comma 6, this one. Correct? You said A, then you said C, and finally B.
I said D.
Gayatri, you said what? D, huh?
D, Mom.
Okay. Okay. We understood this? See, A1 is, instead of giving a blank there, instead of giving nothing there, say like when x is 2, what is the value for y? When x is 2, what is the value for y? So when x is 2, what is y value? Minus 3. So this A1 is minus 3. When y is minus 1, what is the value for x? When y is minus 1, what is the value for x? X is 6. That means B1 is 6. B1 is 6. Correct? So option D is the correct option. B. A not equal to 0, B not equal to 0. The condition that the equation ax plus by plus c is equal to 0 represents a linear equation in two variables is A not equal to 0, B not equal to 0. What do you think is the relationship between the X and Y values? What can you say? Don't see the options. What can you say about the X and Y values? Huh? Either one of them? One is a negative of the other. Huh? Okay. So that is, you're saying one is negative, one is positive. But 0, 0?
Mom, it adds up to 0.
No, I don't want you to, find the correct option. What is that which you observe between X and Y in the ordered pairs given? -2, 2, 0, 0, 2 minus 2. What can you say?
Yes, ma'am, it adds up to 0. If we total like X and Y adds up to 0.
Yeah. X plus Y is 0, no? -2 plus 2, 0. 0 plus 0, 0. 2 minus 2, 0. X plus Y is equal to 0. That only is the equation. X plus Y is equal to 0 is the equation. What is it you observe? This is X, this is Y. X plus Y is 0. When you add the X coordinate and the Y coordinate, it's 0. X plus Y 0. X plus Y 0. That's the equation. X plus Y is equal to 0 is the equation. Or it can also be X is equal to minus Y. Or Y is equal to minus X. When you transpose, right? This X plus Y is equal to 0. When you transpose, you'll get X is equal to minus Y or Y is equal to minus X. Okay, so X plus Y is equal to 0. Because you can see that on the face of the ordered pairs, you can make out when you add these two to 0, 0, 0. So X plus Y is equal to 0. Why I'm saying this? Because you don't have to substitute. Don't try to put all these ordered pairs in this equation and check if it is satisfied. Sometimes you can just guess. From the ordered pairs, you can make out what the equation should be. This x-axis. Correct. That's all. Yeah.
Y is equal to 2.
Y is equal to 2. Correct. Y is equal to 2. Very good. All right. With this, we conclude this chapter, linear equations in 2 variables. Let's stop the recording and give you further instructions.